Hello and welcome to this clip taking us through a level 6 mark question on chromatography. And as with any level question, you should spend a little bit of time thinking and planning about what to write before you get going. So when you're doing your plan, you need to think about what the actual question is asking you to do. So having a read through it, you can see that it says, describe how thin layer chromatography can be used to conclude the identity of sample C. So the second part of the question talks about the purity of sample C. Now it says the purity of sample C was tested using melting point analysis. And the instructions here are to describe what happens to the melting point range as the purity of the sample decreases. So if we think about what actually causes melting point, it's the intermolecular forces in your sample. So if there's an impurity present, how is that going to affect the intermolecular forces between molecules of your pure sample substance? And therefore, we need to think about what that's going to do to melting point range. So quite a few things to consider, so let's get started on our answer. So we start with our TLC plate, and if you've done the practical on this, you'll obviously know that what you do is you draw a pencil line a little bit up from the bottom. Now it says you've got a chemist having two solutions, chemical A and chemical B, and a third solution containing chemical C also contains an impurity from A. So what you've got to think about is how many different samples have you got? So you put it into the solvent, but the level of the solvent must be below the baseline as shown in the diagram. So once your chromatogram has been constructed by allowing the solvent to draw up the components through the mobile phase, you can see that the yellow spot represents C and the blue spots, both of them, represent chemical A. So I've labelled how the spots have been put onto my chromatogram so you can see what I'm talking about. And each spot represents one of the components. So what you need to do is to work out the identity of sample C. So you measure the distance of spot C from the baseline over the distance of the solvent front from the baseline, as I've illustrated in that little sketch there. Okay, so once you've got this RF value, what do you do with it? You can check it against known data for individual compounds, so that will start to give you an idea of what C might be. Now I've realised that through this clip I haven't really talked about the stationary and mobile phases, so I'm going to do that now. I'm just going to fill it in the little bit of space I've got down at the bottom of the screen. So your mobile phase is the solvent and the stationary phase is the silica on the TLC plate. Then it asks us how separation actually occurs. So the separation will be via relative adsorption, not absorption, adsorption, onto the stationary phase. So let's have a look at the effects of impurities onto intermolecular forces in the sample. So the impurity molecules will disrupt the IMFs between the substance molecules. So we're taking our substance to be the actual substance you think is there. If there's an impurity present, it's going to disrupt the intermolecular forces, whether they're London forces, whether they're hydrogen bonds, whatever, in between the substance molecules. So if you've got less IMFs, that means you've got less energy needed to overcome them. So the melting point decreases as a result of this. And the effect seen is the melting point range is extended. So hopefully this covers some of the points you might want to consider when you're doing this type of question on chromatography. So in the meantime, thanks for listening, and until next time, see you soon.